So the next part is calculate the total amount of heat energy required to convert 100 gram of ice at minus 10 degrees centigrade completely into water at 100 degrees centigrade. So how will you solve this? 100 gram of ice at minus 10. So first 100 gram of ice will be converted to 0 degree centigrade ice from minus 10, because 0 degree centigrade is the melting point of the ice. Okay, so fusion or melting will take place at this temperature. So first you have to convert minus 10 degree Celsius ice to 0 degree. After that, from 0 degree Celsius ice to 0 degree Celsius water, keeping the mass constant. There will be no change in the mass. So 100 gram of ice at minus 10 degree centigrade to 100 gram of ice at 0 degree centigrade. Then 100 gram of ice at 0 degree centigrade to 100 gram water at 0 degree centigrade. Next 100 gram water at 0 degree centigrade to 100 gram water at 100 degree centigrade. So these are the three steps. In these three steps we have to calculate the amount of energy. The first one, minus 10 to 0 degree. So here it will be mc delta T, because change in temperature takes place, and here it's the change in temperature of the ice. That means you have to take the specific heat capacity of ice, that is 2100 joule per kg. Here it is given in gram, so we have to take 2.1 joule per gram. Be careful, I'm telling you repeatedly, if the mass is given in gram and the specific heat capacities are given in kg, joule per kg per Kelvin, be careful, convert it accordingly. Convert the mass, it will be easier to convert. Okay, so this will be next. Q2 will be 100 gram of ice at 0 degree centigrade to 100 gram water at 0 degree centigrade. This will be state change. State change means there will be no change in the temperature. Temperature will remain constant at the melting point. That means we have to take here specific latent heat of fusion, that is 336 joule per gram or 336 into 1000 joule per kg. So here I will take joule per gram, so 100 into this. Okay, and the third step, 100 gram of water at 0 degree centigrade to 100 gram water at 100 degree centigrade. So here again there is change in temperature of water, so we have to take specific heat capacity of water, and it is mc delta T, so 42,000. So total amount of heat energy that will be required, you have to add these three. Okay, so this is my final answer. Next, this one is very important. 2 kg of ice melts when water at 100 degrees centigrade is poured in a hole drilled in a block of ice. So block of ice, its temperature is say 0 degrees centigrade. Now I have drilled a hole in that block of ice, and there I have poured water at 100 degrees centigrade. So what mass of water was used to melt 2 kg of ice? So they have told me the amount of ice that is melted. Okay, so first we will find out the amount of ice that is melted, that is 2 kg of ice at 0 degree centigrade will be converted to 2 kg of water at 0 degree centigrade. So what is the amount of heat required? It is this 672,000 joule. This is the amount of heat energy required. So who has supplied this energy? 100 degree Celsius water, mkg, or here it is given in kg, so mkg 100 degree Celsius water has supplied this amount of heat energy. That means this amount of heat energy supplied by mkg 100 degree Celsius water. So mkg 100 degree Celsius water, when it will when it will give heat energy, its temperature will be decreased to 0 degree centigrade. Understood? So this will supply the heat energy, the required heat energy for melting of the ice. So the temperature of the water will decrease and it will be 0 degree centigrade, because 0 degree centigrade ice and 0 degree centigrade water, they will lie simultaneously. Okay, next, so we will find out the amount of heat energy extracted, that is amount of heat energy released by using mc delta t. So m is not known to us. This will be 42 into 10,000 m. Now here I have written APC, so you will be surprised what is APC. It is according to principle of calorimetry. I have not written the full statement here, but in ICS you have to write this. Otherwise your 1 mark will be deducted. If you have remembered while solving the numericals of principle of moments, there I told you have to write POM. According to principle of moments, the clockwise moment is equal to the anti-clockwise moment. Here also you have to write according to the principle of calorimetry, the amount of heat lost equal to amount of heat gained. I hope you will remember, because I was in a hurry, so I didn't get the time to write everything in this solution. That's why I'm telling you in the video. So this is according to principle of calorimetry, amount of heat lost, that is by the 100 degree Celsius water to be converted into 0 degree Celsius water, and amount of heat energy gained by the block of ice when the 2 kg block of ice at 0 degree centigrade will be converted to 2 kg water at 0 degree centigrade. Listen, here I can't say ice to water. I have to mention the temperature simultaneously. Okay, so here this is the amount of heat energy that is supplied by the hot water. So this will be gained by the 2 kg ice. So from this I will be able to find out the amount of water that was taken to melt 2 kg ice. Next, come to this one. Okay, next sum, 250 gram of water at 30 degrees centigrade is contained in a copper vessel of mass 50 gram. Okay, so 250 gram of water at 30 degrees centigrade is contained in a copper vessel of mass 50 gram. Calculate the mass of ice required to bring down the temperature of the vessel and its content to 5 degrees centigrade. So here there are three things: calorimeter, water and ice. Calorimeter, water and ice, just try to understand. Inside the calorimeter the water is kept, and the temperature of the calorimeter and the temperature of the water will be same. Okay, so here the temperature of the water is 30 degrees centigrade. Temperature of the water is 30 degrees centigrade. So temperature of the calorimeter will also be 30 degrees centigrade. It is not written in the question paper. You have to understand that. Okay. Now the temperature of the calorimeter and its content, its temperature should be decreased to 5 degrees centigrade. So calorimeter, the initial temperature is 30 degrees centigrade. Final temperature will be 5 degrees centigrade. Water, its initial temperature 30 degrees centigrade. Final temperature will be 5 degrees centigrade. And who will bring down the temperature? Here I have to bring some amount of ice. Let the mass of ice be m dash kg, because it is given in kg, all the things, all the specific heat capacities and all. So I will convert the given mass in kg, that is 50 gram in kg, 250 gram in kg. That is why I have initially taken the amount of mass of ice in kg. Okay. So initial temperature of the ice is 0 degree centigrade. Now when this ice is converted to 0 degree Celsius, ice is converted to 0 degree Celsius water, and then the temperature of 0 degree Celsius water will rise to 5 degree Celsius water. This point you have to understand, my students. Listen, when the amount of ice is required to bring down the temperature, so ice will melt. Now how is it possible that the ice will melt and it will remain at 0 degree centigrade, and calorimeter and its vessel will be at 5 degree centigrade. So there will be no thermal equilibrium, right? So we can write that equation, heat lost equal to heat gain, in thermal equilibrium. Understood? That is why thermal equilibrium means the hot body and the cold body, they should attain the same temperature. Then only the flow of heat energy will be stopped and they will acquire the same temperature. This phenomenon or this situation is known as thermal equilibrium. That is why don't stop your calculation here. 0 degree Celsius ice will be converted to 0 degree Celsius water. That temperature will rise to 5 degree Celsius water too. Okay, so heat lost will be by the calorimeter and the water. So I have calculated by using MC delta T. So this is the mass of the calorimeter, 50 gram. I have converted this into kg, then into 400 joule per kg Kelvin inverse. That was the specific heat capacity of the copper calorimeter, and this is the change in temperature, 30 minus 5. Then it is plus sign. Okay, then 250 gram water divided by 1000 into specific heat capacity of water is 4200 into 30 minus 5. Okay, so here I have calculated the amount of heat lost by the hot body. Next, so here I can write amount of heat lost by the hot body. Next, amount of heat gained by m dash kg ice. That is, first it will melt, so it is ml, then its temperature will rise to 5 degrees Celsius, that is MC delta T. Okay, the first one is ml, this one is ml, m dash into 336000. This is the amount of heat energy required to convert 0 degree Celsius ice to 0 degree Celsius water. So this is a specific latent heat of fusion in joule per kg, plus this is MC delta T. Take the specific heat capacity of water, because 0 degree Celsius ice has converted to 0 degree Celsius water now. Okay, so you will add all these things. So this is the amount of heat energy gained. Again you have to write according to principle of calorimetry, heat lost equal to heat gain. So heat lost is this and heat gain is this. So you will equate them and you will find out m dash. Next sum, find the result of mixing. This result of mixing sum will come definitely. How to do all this type of sum? Result of mixing type. They have given 10 gram of ice at minus 10 with 10 gram of water at 10. So it depends on how much ice will melt. So that will decide the resultant temperature. So first we will find out what is our heat reservoir. So here 10 gram of water at 10 degrees Celsius. If the water at 10 degrees Celsius changes into water at 0 degrees Celsius, then it can release some amount of heat energy. So that will be our heat reservoir. Using that amount of heat energy, this ice will be converted to water. Okay. So initially my hot body, the temperature was given 10 degrees centigrade, and T final will be T degree centigrade. We don't know what will be the final temperature. First we have converted to heat lost, that is 10 degrees centigrade water to 0 degree centigrade water. So let us write here 0 degree centigrade. Okay, because first we will do that change, 10 degree to 0. So this is the amount of heat energy released. Now amount of heat energy gained by the cold body. Now the ice is there in minus 10. So at minus 10 degree centigrade, it will not be able to melt. So first minus 10 degree centigrade should be raised to 0 degree centigrade. So the amount of heat energy gained will be 210. So this 210 amount of heat energy will be extracted from this 420 joule. Okay. So this 210 amount of heat energy will be extracted from this 420 joule. So from 420 joule, 210 amount of heat energy gone. So remaining amount of heat energy is 210 joule. Now this amount of heat energy is not sufficient to melt the complete 10 gram ice. Okay, because the 10 gram ice requires at least 3360 joule to melt totally, because M into L will be the required amount of heat energy. So only I have 210 joule, but I require 3360 joule. So it's quite clear from the picture that total 10 gram of ice will not melt. So how much amount of ice will melt? So it will be like, I have to find out कि I have only 210 joule, that is equal to ml. So L is known to us, so I will find out M, the amount of ice that will melt. That is only 0.625 gram. Remaining amount of ice will be left as usual. Now if the solution has, if the mixture has ice, then and the mixture has water, so it should be 0 degree centigrade, right? So the temperature of the mixture will be 0 degree centigrade, because it should be in thermal equilibrium. Otherwise heat flow will take place. So I have to set the final temperature in thermal equilibrium. So ice and water, they are existing simultaneously. It means that the temperature will be 0 degree centigrade. Now this question can be changed by changing some data. Like if I give say 100 gram of water, so it should release, it will release then more amount of heat energy. Then the scenario may be different. So what will you do? You will first calculate the amount of heat released. That will decide how much ice will melt. Then it may happen कि the amount of heat energy released by the hot water is so much that the ice will first melt. So ice, 0 degree Celsius ice will be converted to 0 degree Celsius water. After that the temperature of water may rise. I think this kind of question you will get in your exercise, in your example. So do follow the numericals given in the example. So this kind of question you will get there. What will be the resultant temperature? Then you will see the resultant temperature will rise. Okay. So it completely depends upon the heat reservoir. Clear?